Standard formation enthalpy refers to the delta H. If you imagine that you're going to make 1 mole of something, okay, from the elements in their standard state, the delta H for that reaction is called the standard enthalpy of formation. And you see that F right there? That stands for formation. Or you can also see that written as delta HF after the H, okay? So the delta H of formation refers to the delta H of reaction in the case where you're making a mole of whatever substance you're interested in from the elements in their standard state. What do we mean by standard state of an element? That's the most stable form of the element at a particular temperature. Unless otherwise specified, we're just going to be dealing with room temperature, 298 Kelvin. So for example, the most stable form of oxygen is O2. Okay? The most stable form of nitrogen is N2, it's diatomic molecule in the gas phase. So, like I said, values of standard formation enthalpies are tabulated to facilitate calculation of delta H for any reaction. Okay? And how are you going to do that? Well, before we show you how it's actually done, let's look at this one right here. Let's see if we get the definition of standard formation enthalpy down. Okay, so for which of the following is the delta H of reaction equal to the delta H of formation of NH4Br, ammonium bromide solid? Is it A, B, C, or D? All right, so let's see. What's the definition of standard formation enthalpy? That's the delta H for a reaction where you make 1 mole of whatever it is you're interested in. So which one can you eliminate right here? C. This is 2 moles, so that's wrong. Okay? And you're making it from the elements in their standard state. Okay? What's the standard state of nitrogen? Most stable form of nitrogen gas is N2 gas, right? So this one is wrong. What's the most stable form of hydrogen as an element? Standard state of hydrogen is H2 gas. So this one is wrong. Okay? What's the most stable form of bromine? Br2 is also diatomic, but it's a liquid. Okay, so this one is wrong. Okay, and this one is wrong. That's Br2 gas. And so, what's the correct answer here? D. And let's just make sure it's correctly balanced. 1/2 times 2, that's a mole of N2. You have 1 N2 on the right side. 2 times 2, that's 4 moles of H. You have 1 mole of N on the left, 1 mole of N on the right. 4 moles of H on the left, 4 moles of H on the right. 1/2 times 2, that's 1 mole of bromine on the left, 1 mole of bromine on the right. So your equation is balanced. Okay, so the delta H for this reaction, reaction D, is what we would call the standard enthalpy of formation of NH4Br solid. Okay, let's look at this. For which of the following is the delta H of formation equal to 0? N gas or N2 gas? I lost my clicker again. Ready? Let's see how we're doing. Okay. B is a popular answer. Okay. You have a chance to change your answer before I close it. Okay. Correct answer is B. Why B? Oh, I have to stop it first. Why B? Okay, what's the delta H of formation of N? It's of making of 1 mole of atomic nitrogen from diatomic nitrogen, right? So to balance this equation, that would be that. What's the delta H formation of N2? I have to make a mole of N2 gas from what? From a mole of N2 gas. So delta H for this second reaction right here is going to be 0. How do you make a mole of N2 gas from a mole of N2 gas? Do nothing, right? So delta H should be 0. How do you make a mole of nitrogen atoms from half a mole of nitrogen gas? You have to break those bonds, right? To break bonds, you need energy. So delta H for this is in fact going to be a positive number. So it's going to be an endothermic reaction. You have to pull apart those nitrogen atoms.